This is assessment 1 for MTC503, professional experience 3, using data. Hello, I'm Beau Logue. This is assessment 1 for MTC503, professional experience 3, using data to inform teaching and learning. We're looking at the local scenario here, which is a remote school. You can see the desert school. The focus of the review is on numeracy in secondary school years 7 to 12. As a part of this review, we're going to use a process called data-driven decision making, which involves 4 steps: collecting the data, examining the data, interpreting the data, and then making a decision based on what we've learned. This is a good point for us now to have a think about how we make decisions daily in our classes. What information do you receive? What do you do with it? How does it change your plan for the class? The continuous improvement cycle has 4 major steps. We're focusing on 2 of them here. Firstly, identifying the problem and identifying possible solution. So to be able to implement data-driven decision making, we need to have data. To choose effective data, we really need to understand a bit about it. Data can be either qualitative or quantitative. Qualitative data is more of a story. It's quite open. It can contain any information that the sources offer to you. Therefore, it can be a bit difficult to collect and analyse and can be surprising in its results. Quantitative data, however, is quite restrictive. There's only limited options for the sources to choose from, and the process of collecting the data can really have quite a significant effect on the results. Therefore, we really need to be careful to control all of the variables that possible. The ideal situation is really a mixed mode scenario, where qualitative data can direct to the major themes, and then quantitative data can support or reject these themes. To undertake a review of data, we need to have some data. Fortunately, at the moment, there is no shortage of data within the world. Data is really any form of information. It can be government reports, assessment results, and surveys. So given the amount of data, we need to understand a bit about what different sorts of data there are. One of the most important distinctions is between primary and secondary data. Primary data has come directly from the source, whereas secondary data has come from someone else undertaking the data collection and analysis. While secondary data can be a lot more convenient to read, we need to be aware of the potential bias that's introduced as a result of that initial data collection and analysis. This would be a good point for us to think about where we've seen data go through a number of reports and then be misused. The data take a review of data, you need to have some quantitative data. Unfortunately, at the moment, there is no quantitative data. It's very precise. Data is really any form of information. We need to use reports, assessment results for that initial question that was being asked. Given the amount of data, we need to understand a bit about what different sorts of data there are. Quite susceptible. The most important is the ability of having primary and secondary data. The primary data has come directly from the source. Here I've focused on 4 data sources. 3 are system-level resources, taking data from the whole of Australia, and 1 being our school-level results. The system-level sources are footprints in time, closing the gap, and the independent reviewing regional, rural, and remote education. Whilst the school-level data is from NAPLAN. Each has its own benefits and limitations, which we need to keep in mind as we're looking at them. Footprints in time, it's a relatively small sample size. Study's got 1,200 participants. That's 3.2% of 7-year-old Indigenous students in Australia. Footprints in time, it's a longitudinal study. This means that the same families are surveyed, which really assists in removing a lot of those variables that need to be controlled for fair quantitative assessment. Closing the gap, it's a report that looks at quite a variety of sources. In the area of numeracy, it looks at NAPLAN results and the census data. The report selects the data and presents it in a format that tells the story of what's happening across Australia. And the NAPLAN data, it looks at the results directly from our assessments that was undertaken at this school. Depending on the type of the data, it can be examined in different ways. Quantitative data is well suited to being presented graphically. However, caution really needs to be exercised in presenting the correct graph for a given data set. Qualitative data needs to be distilled down a bit more to become a manageable set. This can be done with a top-down approach, where data is placed in predetermined bins, or a bottom-up approach, where the data determines the groups and common themes. Secondary data sets generally have already distilled this data down and present an indicative set for the current situation. This graph is from the Closing the Gap report and reports on students completing Year 12 or equivalent, where we can see results have improved in all categories since 2006. The same Closing the Gap report presents yearly data based on numeracy, with an improvement being able to soon be seen. However, results are fluctuating up and down, having dipped to the lowest in 2013. This has come from the NAPLAN results across the country and makes us ask a few more questions. For a look at the school level results, NAPLAN, via the My Schools website, presents data for individual student improvement. This data is available when an individual student completes NAPLAN assessments at the same school in 2 successive cycles, such as Year 3 and 5 or Year 7 and 9. Out of potentially 33 results here, only 4 have data available. This shows that the attendance and transience levels of the schools, and the data recorded here really isn't going to be a fair representation of our students, given the limited sample size. Whilst the individual student improvement data would have been the best for some data analysis, here we're going to have to use the whole cohort instead. Here's the raw results, which in this format really has pretty limited value for us. Recognising that this data is from the whole cohort, we go through and just check out for outliers. Statistically, the 2015 and 16 Year 7 results are outliers. However, it's mostly driven by the poor Year 7 result in 2016, so we will need to keep this point in mind as we're going through. Having the data is one thing, however, using it effectively takes a level of interpretation. Shaddock and Hattie outline a series of steps to be undertaken. They are to verify the data is relevant, cross-reference the data, watch out for floor and ceiling effects, avoid complexity in your analysis, look for surprises, and only use data as the starting point. Let's have a look at the data that we've just seen and analyse it against these points. So here's that Year 12 attainment data again. Is this data relevant to us in determining high school mathematical performance? Given the values for very remote Indigenous students, it appears that the attainment rates are a lot lower than our numeracy standards that are being achieved. Additionally, data is only available every 5 years, which limits the benefits of this data set to us. Cross-referencing the data with the minimum numeracy standards, we see a bit of a correlation here in improvement. However, the yearly data from the standards indicates that there's a lot more of a story to be told than what you're seeing. You can see a bit of a ceiling effect happen with the non-Indigenous data. It's starting to approach 100%, which we can't go beyond. This has the effect of making it appear the difference between Indigenous and non-Indigenous achievement is reducing, whilst actually the non-Indigenous results are being capped at the ceiling. Here's a graphical representation of the numerical NAPLAN data that we had before. Have a minute to look at it and discuss with those sitting around you and consider the steps of interpreting data. The Year 8 data here has the 2014 to 2016 line dotted. This is that value of the 2016 Year 7s that was identified as an outlier earlier. We can see that there appears to be a trend in the Year 7 to 9 improvement being limited. That's shown by that flat line at the top of the 2 top cohorts. So this graph looks at the improvement in scores made over a 2-year period. As with the last graph, we're considering how the same cohort compares between NAPLAN assessments. The orange Year 7 result is the outlier we identified before. So if we ignore this value, it appears that there's consistently improvement, other than in that Year 7 to 9 group, where we see some cohorts do well and others have very little, if any, improvement happening. This variation in performance in students going from Year 7 to Year 9 warrants further investigation. So the Independent Review in Regional, Rural and Remote Education, it's a qualitative study. It reports on experiences in a written form. So here we're looking for it to identify potential impacts on Year 8 or 9 students. So being a qualitative report, it's more open to any results occurring. This report identifies an impact at Year 9, where students begin to ponder their future after school. The lack of career guidance and conflicting cultures are identified here as issues for these students. So it's time for some action here. We've collected the data based on our hypotheses that secondary students have poor numeracy results. The potential cause has been identified as a lack of direction of what the students want to do after school, making the school seem less valuable for some of the students. Next step is for us to determine an action. Potential student solutions could be addressing the students feeling lost and assisting them to determine what pathway to take with their lives. Once the students feel they have a purpose, then the curriculum and delivery of this can be modified to improve the relevance to the students. The validity of this potential solution or finding another solution should be researched using an action research method. Additionally, it's possible that similar effects continue through to Year 12. Remember, this NACLAN data only looks at students up to Year 9. So to wrap this up, we've identified that Year 8 and 9 students have limited improvement in their numeracy in some cohorts. Maybe this is a result of them losing interest in the content and could actually be continuing through into upper school. We don't have the data for that. The teachers really need to be aware of these trends and make an effort to keep these students engaged.